All right, let us get going with the final piece that I wanted you all to learn this week, and that is we're going to start playing with AI. This is actually another design pattern, so it's going to be a state machine. State machine is um, I would call it a intermediate AI. It is way above just a simple if then else run of statements that would could be used to direct a helper, an enemy, whatever it is, right? Oh, so um, yeah, so it's gonna be way above that, but it's definitely not gonna be like behavior trees or any of the advanced AI that we just won't be getting to in this class. But a state machine will be more than enough for you to do any AI that you wish to create for this course, and especially for your boss fight. So I felt like it would be pretty important for us to go ahead and work through that. So what we're going to do is um, we're going to first start by activating or turning on AI navigation. So what we want to do is go up to our package manager. Once again, if you don't have it there, Windows Package Manager. I keep it here. We want not my assets that was left over from our previous video, but we actually want to go into, I believe it's Unity Registry. We'll find out here shortly if that is correct. We want and are looking for AI navigation, and there it is. So, yep, it is in Unity Registry. Just scroll down a little bit in the packages AI navigation, and we're going to go ahead and install that. And so once that is installed, we are now almost there. AI navigation, surprise, surprise, allows for AI to navigate. And that is definitely what we're going to want to do. So we've got that now in our scene. You can see it here in the packages, not in our assets, but the packages. And so, and with that, we now have this handy dandy little box here, AI navigation. It just hangs out in the window. You can turn it off. I believe you just turn it back on here from AI navigation if you want. Um, Amazingly, there's an obsolete version of the same name, which we won't use. All right, so what we want to do, we have our floor, which, if you remember, is a plane. If you don't remember, here it is. It's a plane. And what we're going to want to do to that, we want to add a nav mesh surface component. So we're going to go to our add component, and we're going to type in nav mesh. Sorry about that. Nav mesh surface. And it's going to pop this one up here. And then what we want to do, we don't really care about it too much. We're just going to go ahead and bake it. We're going to say that is our nav mesh at the moment. And you'll see it's created a nav mesh that the blue is everywhere that currently we say that the player or that our AI can travel. Currently, the AI cannot get completely close to us. We could change that if we want. It cannot get to our gun and cannot interact with our target. All these things can change, but for right now, that's perfectly okay for us. All right. Then we want to go ahead and for this example, we're going to go ahead and we're going to create a robot. And that robot is gonna love to sleep, and it does not want to do anything else other than sleep. However, it will work when the owner's in view. All right. So what we're saying is we're creating an AI robot who's a digital version of me when Professor Ellertson is around or is not around. That doesn't sound right, but we're going to go with it anyway. All right. So we're going to go ahead. We're going to create our little robot. We're going to save the scene as it currently is. We're going to add to our scene a cube. We're going to move the cube out a little bit. We'll put it on the other side of the gun. Why not? Zoom in on it. It is currently floating above the ground. We do not want it to float above the ground. So we're going to set its Y position to half. I'll just make this an even 20. It doesn't matter, but we're going to do it anyway. And you can see it intersecting with that nav mesh. All right, we're going to go ahead and into this cube, we're going to add a cube. Because that, I mean, I guess that's kind of a robot, but I don't know. Let's make a different robot. So we're going to add a cube into our cube. We're going to pull that one up, just the childed cube up just a little bit. We're going to go to our materials. We already have, we don't have a full block yet. So we're going to take the gun, we'll duplicate it. We're going to just call it black. Oh, not black. We're going to go with black. And it is going to be black. Amazing, right? And we are going to go ahead and also create, so now we have black, we're going to create, Control D, we're going to create a blue, and duplicate the blue, and we'll make a red, and then we'll go into the blue and actually make it blue. That blue looks fabulous. And then we'll go ahead and make this red, fabulous red. All right. We're going to go ahead and change this to body. It's going to be our AI's body, a robot body, and then we're going to change this to the head. We're going to transform the head because that is a really weird head. We're going to make the position of it 0.75 in the Y, and then we're going to scale this down to 0.5s. It kind of looks like a little bit of a head, right? And then we're going to, I mean, kind of a robot, kind of, I mean, we'll add black to the body. Why not? We can keep the head white. That's fine. But I mean, what's it looking with, right? So let's go ahead and with the head, we're going to add another child of a cube to it. And instead of cube, we're going to actually call this scanner. So this is what technically is going to be scanning to see if we're around. And if we're not around, then it's going to nod off and take a nap. And we're going to then move this. We're going to do 0.2 in the Y. We'll move it up a little bit. And then we're going to scale it out 1.25 in the X, so a little bit wider. We're going to shrink it down in the Y, and then we're going to once again go 1.25. And then we're going to, because it's scanner, we're going to make it a red, right? So that kind of looks like a robot. I'm going to give it a robot. That is my level of animation or modeling. So that's what we're going to go right. So we've got the body, and attached to the body is the head, and the scanner of the robot. Okay. So what we need to do is go ahead and we're going to use oh, sorry about that. We are going to go ahead and use a raycast to determine if the robot can spot the player or not. So basically, it's acting as a line of sight. What we want to go ahead and do, because we're going to be shooting this raycast from this center position of the scanner, that raycast could have a potential of hitting everything. And so we don't want it to see itself and go, oh, I don't see the player. So so this is where our layers come into play. So there already is an ignore raycast layer. Oh, sorry about that again. Um, and so we've changed the layer, and it's asking us, do we want to change it for just the object? So we could change it just for the body, or do we want to change it for all the children as well? And so in this case, we want to say yes, change it for the children. We want all of them to ignore the raycast. So if you click on them now and then the layer, they all say ignore raycast. So that is going to allow us to do that. And so, what is going to be moving around? The body is going to be what's moving around our environment. And so, because of that, we need to select the body, like I have here, and go ahead and we want to come in and add a component. We already had nav typed in there, so it's going to just remember that. And for this, we want a nav mesh agent. The nav mesh agent is stating what exactly that this is an AI that is going to be moving around the nav mesh, right? We're going to be using that to do our be able to move around it. And we can just currently leave this as is. I think this is perfectly fine. We could play with acceleration, speed, angular speed if we want to, but right now, I think we're okay. So, what we want to do next is, if we scroll out, for the most part, this little robot is going to see the player no matter what. We're going to actually, to make sure that happens, we're going to move them over a little bit, right? We don't want that gun in the way. We can also set the gun to being ignoring the raycast. I'm not going to worry about that right now. We'll just move them out of the way. And so pretty much in this big, huge environment that we have here, right, there is nowhere for this little dude to take a nap. And I feel bad for him. He works really hard, I'm sure. So we're going to give him some spots to hide. So I'm going to go ahead and I'm going to create an empty game object just so that we can hide them. I'm going to call that empty game object walls. And I'm going to move it up to right next to our floor because it's there. We're going to go ahead and switch this to environment. And then we're going to add into here some cubes. And so what's nice is because I created the cube as a child of the walls, it inherits the environment. I could go and switch that if we didn't need it, but we're going to leave it. And so we're going to duplicate this 8 times. We're going to give him 8 walls to hide behind. And then let's go ahead and... really doesn't matter where you're going to place these. We're just going to move these around for a moment. We're just going to kind of, I don't know, here, kind of go to all the corners, I guess. And then why don't we do kind of a closer one, and a closer one, and a closer one. And then we're going to go ahead and modify these. And then this one, maybe let's kind of just hide this right here in the edge behind that. Okay. So now we've got these. I mean, these are little tiny walls. It is not going to do much for us. So let's go ahead and we're going to select all the walls. And we're going to scale them. Let's make them about 5. We can go a little bit higher now. Let's go like 8. He's 8 meters high, and then I mean they got to be some distance, and we'll do some rotations. Let's give them like 20. That gives us some actual like space for this little guy to hide. You know what? Let's give him a little extra room. A little nice tonight. Everybody needs a break. All right. So then we've got these. We'll leave the initial cube kind of in this position behind the target. And then let's go ahead and I'm going to rotate. I'm going to hit E after I select cube 1. And I'm just going to grab the Y rotation. I'm just going to give it a rotation sort of like that. Same thing with 3, but I don't know, that looks fun. Let's do this one, that. Really doesn't matter. Just have it so that there's some differences, so that the little guy has some places to hide. We'll give it a that, this, and you know, that looks pretty good. That covers a lot. Okay, so now we've got a playing field that has a lot more spots where this little dude can hide. All right, and you know what? Let's go ahead. That's going to take him a little while. We're going to bump his speed up to a good solid. We'll double it. We'll go up to 7. Okay, so let's go ahead and save this. We're going to go ahead and minimize walls. One thing that we do need to do is go into our bullet prefab, because now we have other things in our scene that our bullets could hit, right? So we want to, we're going to go through and first, I'm going to go ahead, let me find that code. It's over here. It's hiding. We're going to bullet collider. We want to on collision enter. So we want to first check and see. We're going to do a couple things. Let me do one thing first. We're going to get to that in a second. The only thing we really want the bullet to affect right now is the target. And so we're going to go ahead and add a tag to the target. And in this case, we're going to add a tag that is literally just target. And so we're going to come back to military target. We're going to click and add target as the tag. And then we're going to we want to do two things, right? So if collision dot collider, so we're checking what it's colliding with, dot tag. So does the tag of what it hit equal target, right? That's what we just set up. Oh, wrong one. Got to do the open bracket. That's always helpful, right? So as we see, the military target, its tag is target. We could also do name, but this, maybe we put in some other targets in there, right, that aren't specifically the military target. So everything under that's tag of target, we want to go ahead and that's where we're going to do the destroy it, increase the score, and return it to the pool. If it's colliding with anything else, I don't care if it's the robot, the floor, anything, all we're going to do, so we're going to do an else here, else, all we want to do is we're going to return the bullet to the pool. So hit the target, great, the target's destroyed and is removed. And the score's increased, right? That's the only way we're getting an increase in our score. Otherwise, all you're doing is returning the object to the pool. So you hit one of those walls, it's not going to give you a score and it's not going to remove the wall. So we're going to go ahead and have that updated that way. I'm a stickler. I'm going to remove that extra. It's fine. Okay. So we have that now. So that's not going to cause any problems to our walls, anything like that. Now, we want to come up, the final thing we want to do with our walls. As you can see, the nav mesh goes right through these walls, and we don't want that. And actually, we're going to first go ahead, we're going to bring these up a little bit, make it feel a little taller. I think that's about right. And then what we're going to do, we don't want the robot walking through the walls. It's not that cool of a robot. It's not futuristic. It is metal, and we'll say that these walls are a beautiful white marble. So what we're going to do, we're going to select once again, all of those. So click on one, shift, click on the bottom. That selects all of them. And what we're going to do is we're going to now add another component, this time a nav mesh obstacle. We want to make sure that the nav mesh thing is clicked. And that should have put a little thing around our box. We've got it as a box. They're probably a little too tight. So what we're going to do is we're going to double these. Oh, we don't need that big of a box. We're going to not double those. We're going to say 1.2. 1.2. So that should be a little bit around it. And maybe I have them up too high. So let's just do 1.2, 1.2 with them all selected. And then we're going to drop this down to 1. And then we're going to go ahead and with them all selected again, we want to click the Boolean next to carve. Oh, actually click it. And so now you can see there's a white spot around it, which maybe is still a little too big. So let's cut this down to 1 in that spot. And maybe we'll come out a little bit further here. We'll go like 1.4. All right. So what this has done is created a white area around each one of these. And so, and you know what maybe we'll do so that nothing weird happens, if we select, I think it's the top one, this one here, we're gonna actually increase this a bit to include that target. So it's a little wider, but now that robot's not gonna be able to sneak behind the target. In this case, because it was so close, I think that's the best choice. All right, let us go ahead and let's save this. And then let's create, we need the robot has to be able to move, and it needs to be able to move to certain spots. We could have it just randomly pick a spot, but in this case, we're just going to pick the 5 dirtiest areas that it should be cleaning, right? And so we're going to just create another empty game object because I like empty game objects. We're going to call these destinations. And then we're going to go ahead and also in these destinations, we're going to add 5 more. Oops, Control D. So we're gonna make a total. We'll just do total of 5 areas where it's gonna go, and so then all of these are gonna be. We'll call them. We'll call them location. Why not? I think that's good enough. And so if we do that, it changes all of them to that, and then we're just going to call this location up. Call this come on, location 1. The other one was 0, which is fine. 2, 3. Okay. And so let's take location 1 and let's put it over here. It can be kind of that area. And then location 2, you know what, we could be over here. These don't really matter where they are. 2's over there. Let's put 3 up behind. Let's make sure it's out. Yeah, I had a feeling. Let's make sure it's actually on the playing field. And that's going to need to come up a bit, which we'll fix that in a minute. And then this one, I don't remember where they all are at the moment. So we've got there. Move this back in just a bit. That one should be fine. It is okay. 3, I want to bring that a little bit. And 4, great. Okay. And then we want these all to actually go up. Otherwise, it's going to be really confused. So we're going to bring these all up on top. I don't know why it put them down that low, but it did. And we're going to just drop it right there. Oh, it's because this, now let's change that for a moment. It's because this didn't get set at 0, so I don't know why that did not get set at 0s. All right, let's double check these, make sure we're okay. We got a destination there. We've got a destination that is now, it appears off. Hold on. It is. Got a destination here now. Destination there. That got moved a lot. And that one's off. Okay. Terrible. We're going to move this guy over here. Actually, we're going to put this one up in the middle. Just in case the player's hiding in the back, then it's got another spot to go and work. Okay. Now that we've got that correct. All these, once again, should be at Y0. I don't know why that came in wrong, but it did. And then actually, you know what? Let's go ahead. We're gonna make all these 0.5 above. And the reason we're doing that is because the body is 0.5 above. And it's going to be measuring those exact points. So we want to do that. Okay. Let us go ahead and we need to create the start of our robot state machine. So, big surprise, surprise, we're going to go to our scripts. We could actually, and I probably would recommend this, create a subfolder in here and call this state machine. This could be like robot state machine, it could be then enemy state machine, it could be boss state machine. So if you have multiples and you want to make sure you keep them separated, that's a great way of doing it. So we're just going to put it in the state machine folder within our scripts because these are all scripts for it. And we're going to create a series of scripts. And so we're going to create them all right now, and then we'll go through them as we go. So the first one is going to be robot state. And I'll explain what all of these are as we go. It's thinking. And then we're going to create a second script, and this one is going to be robot state controller. And then, once again, we just have 2 states for this robot. We're going to have, so we need 2 more scripts. We need robot working. So it's running around, right? The player can see it. It's going to move. And then a final script, which is robot sleeping, right? Because that's its goal in life, is to sleep as much as it can. Okay, so the robot state is where we set up what are the different states that the robot has or can have. And this is going to be a little different than what we've used before, unless you've done a state machine again. So what we're actually, this isn't even going to be a mono behavior class, right? This is going to be different. This is a public, it's an abstract class, and it's called robot state. And so this is because it's abstract because it can be used in lots of different ways, and you'll see how that's used in a bit. And then we need to add a single variable to it. And so this is a protected, and this is it's protecting the robot state controller. And we're going to call that the RSC, the robot state controller. This is saying that this is connected to it. It can't be any other way. It's really important. And we'll get into that. And so we can delete these because none of these are going to have anything to do with our states. We're going to create 4 different states that it can be. And the first one, we're going to do a public. All of these are going to be public because they need to be accessed from other scripts. So we're going to say public. This is another abstract. It's a void. And we're going to check transitions. And what this one does is this is going to check and see basically every frame. Do I meet the conditions to transition from one state to another? So do I meet the conditions to switch from working to sleeping, or do I meet the conditions to switch from sleeping to working? This could be any type of transition, but do I meet that condition? Then we've got another public abstract void. It's not update though. It is called act. And this is going to be when I'm in this state. So if I don't transition, this is what I do. This is the actions I do during this phase. And then we have 2 public virtual, I can't spell virtual, voids. One is on state enter. I'm sure that you can figure out that this is connected to, oops, sorry, it's not, and then it is it's a function technically. And so this is going to say, okay, the moment I enter this new state, this is what I'm going to do. But I'm only going to do this once, the first time I enter the state. And so then we have a matched one, which is a public virtual void on state exit. Same way, right? Same thing. I have found out that I meet the qualifications to transition from this state to another state. And so before I switch to the other state, here are the things that I need to do to close up the books before I move on. And then the final piece that we need is a public robot state controller RSC. And yep, there it is. It knows what to do. This.RSC equals RSC. And so this is going to connect everything together. And this is the last time we need to touch it. We can add in other things here. This is not the only 4 things that it could be. This is going to be what it goes through, and I'll show you soon how these all get pulled. Okay. It's basically setting the different states that are available for the robot, so there could be more. All right. Now, our robot state controller is what's coming next. And let's go ahead and open that. All right, so this does stay a mono behavior, but we're gonna add one thing to the top. We're gonna be using Unity Engine .ai. So because this is going to be AI based, we want access to the nav mesh controller, which is AI based. We need to be able to access the AI. Okay, we've got a bunch of variables to add to this. We're going to go ahead and set this up. We actually want to set these up as publics instead of, I'm always tempted to do a serialized field for these, but it doesn't work because we're going to actually be calling these from the other states. And because we're calling them from the other states, we need to be able to have access to them from there. So we're going to have a public game object. We're going to call the player, my normal convention, a public game object, which is the scanner. We need a public robot state, and we're going to call this the current state. So what is the current state of the robot? Is it working or is it sleeping? Then we're going to create a list. And these are going to be the transforms. And these are these are going to be our destinations. Right, we said that there was a few spots that they could be. And so this is where we're going to list those. So we're going to new list transform. And we'll populate that in Unity. And then we need to say that we have a nav mesh agent. So this is going to be our robot, and we're going to call it the robot. Right, we already set up nav mesh agent on it, so that works. We need to have another transform, which is tracking its current destination. Right, where is it going to? And then we're going to add in two materials because we're going to change that scanner. We're going to change it from red to blue, depending. So we're going to have a red material and a public. I don't know why it chooses green as the next option, but it does. Blue. So we will. Oh, sorry about that. We will go ahead and switch the material from red to blue as needed. So, in our start is where we're going to first state the robot is equal to, so robot, which is the nav mesh agent, we're going to get component nav mesh agent. Right, so we're going to assign that nav mesh agent to the robot nav mesh agent. So now we can just refer to that by robot. The current, we're going to, all right, I'm going to start adding other things here. So we're going to, we'll just use in between. It doesn't matter where they go. Another function we're going to have is random destination. And I believe that this is a public, because we need to be able to call it a public. We're going to be returning a transform, right? So we need to be able to return something random. So we're going to have a list of destinations, but we want to just pick a new one. So we want to always verify that everything is as it should be. So destinations count is greater than 0, right? We need to make sure there are destinations they can go to. And then we're going to create an integer. Just for this, we're going to call it RD for random destination. And then we're going to do a random dot range and this is going to be 0 to destinations.count. So it's going to pick an integer from, in this case, 0 to 4, which gives us our 5 destinations that we have. And then it's going to return the destination and RD. So out of destinations is going to go to that specific elements on it and return that specific location. Once again, like before with our bullet stuff, our random destination function is still red because we have a way of not returning something. So if there are no destinations in the count, we're just going to return null, which allows us to do that. So now we can actually, into our start, we're going to give it its first destination. So we're going to say its current destination is equal to a random destination. Go ahead and find out what that random destination is, set that as its current first destination. And since we already have it there, it's perfectly okay. We're going to go ahead and set state to, no, are you? Did I miss one? Oh, we got to add this first. All right, hold on just a second. So we're going to delete that for a moment. We're going to go under update. Actually, we can, nope, we have to keep the update. And I'll show you why in a minute. We need to create a public void set state. So this is where we set what is the state the robot is in. So robot state, we're going to call RS for robot state. And then we're going to say if the current state is not nothing, right? We should have a state which we're going to set in start, which is perfectly fine. We're going to set the current state on state exit. So we're going to go through, if we're changing a state, if we're setting a state, we need to first go through the current state's state exit. Then we're going to say that the current state is now the robot state. So if the new state, if it was working and it's going to sleeping, we go through the on state exit of working, complete whatever needs to be completed there, then change our current state to sleeping, which we've passed in, and then as long as it's still not null, which is, once again, it should not be, we need to go through the on state enter. So we go through now the on, didn't spell enter right. We go through now the new states enter if we're changing the state. So now what we can do is we can set state at the very start. We're going to say it's a new robot working, right? It should start out working because it's in view of the player. You can change it. It is set to this. And we will robot working will oh, we don't have it. Hold on, I might have named it wrong. No, I've got it. We need to set this. It will eventually, the red will disappear. Trust me. Trust me on that one. The other thing that we need, we have the random destination with the set state. So now we just need to do our updates. And basically the update is going through and doing our checks. So we want to check the current state first every frame. We want to check the transitions, right? Does this meet the qualifications to transfer from one state to the next state? It's now out of sight of the player, go to sleep. And so if the check transitions doesn't lead to a change of state, so then that would come down to the set state. If that is not the case, then we want to go ahead and do current state dot act. Now it's going to go through the actions of that actual current state. And we are currently good with this. I'm going to save it for now. Once again, I didn't realize this is red, but that's perfectly good. So let us go into robot working. I've already opened it up. The reason why that was red is because this robot working is saying currently it's a mono behavior. It means it's its own thing. It's its own code, its own set of behaviors. And for this, because it's a state machine, we don't want it to be on its own. This is all connected to the robot state. So we want to do robot working dot robot state. And we need to make sure that this also has using Unity engine.ai. Okay. This public class is totally not what we want anymore, right? This doesn't match what we set up in our states. So all of this gets to go away. And now we need to state here that once again, sorry about that. We want to state that this is public. It is robot working, which is part of the robot state controller, which we've set as the RSC, right? And it is calling from the base RSC so this is calling back to what we set up, because you'll see here we're going to do a public override. So whatever is doing, override it with the on state enter. It's always going to give you that start. We're going to leave this blank for the moment. We want a public override void check transitions. Once again, we don't need that. We need a public override void act. These are implemented, we're good. And then we need finally a public override void on state exit. Now that this matches what we have in our robot state, we have lost our red line there, and we've lost our red line here. So now we have a state that's all connected through. We're going to, real quick, make life easy. We're going to go through, and we're going to also do sleeping. And then we're going to come back in. And make the changes. So once again, we are using Unity engine.ai. This is not the mono behavior like last time. It's the robot state. And then we're going to save ourselves a little coding. We're going to come back and we're going to copy all this. We're going to replace all this, and we're just going to, I'm lazy enough to do that. And now we have sleeping set up as well. Okay, so as you can see, each time it's going to, we're going to have a spot for when it enters this new state, Then it's going to check and see, well, should I be in this state? Do I meet some criteria to move out of this state? So if I do, we're going to change that. Then we're going to have some form of action. And then eventually it's going to leave this state. Something's going to change. That transition's going to happen, and we're going to leave to the next state. All right. So let's go back. Well, why don't we do it while we're here? Let's go ahead and what we want to do. So the base RSC allows us to call back to our robot state controller. And that's the reason why we have everything here as public. It allows us to call back to this and get that information. So for sleeping, what we're going to do is, if it's sleeping, we're going to say the RSC, and we've already set up the scanner, and we're going to get the component of the scanner, and it is actually the renderer. And we're going to change the material of that scanner to equal the RSC blue. So if you have hold on, let me see why this is causing a problem. Did I get oh, huh. Equal signs, they're always helpful. Code, it's great. So when the robot goes into sleep mode, it's going to go from a red scanner to a blue scanner to show that it's sleeping. And so then what we're going to do is we're going to check our transitions, right? So we need to see, is there something that's leading from this transition to another? And so we're going to check the transition, and that's going to be getting the distance. Because what we're going to care about, we're not, the robot's in sleep mode. And so what we can think of this is the player sneaking up on the robot and then making the robot sensing with the one sensor that's still awake, a little bit of disturbance, and then it pops awake. And so this is going to be distance based. So we're going to just run a quick float that we're going to call dist for distance. And we're just going to get the distance. So it's a vector 3 because it's two 3D objects. Dot distance. We want to get the distance of the RSC transform position. So this is the robot's position. Nope. And we want the RSC player transform position. So this is going to get the distance between the player and the scanner. And so, or sorry, not the scanner, and the robot itself. And so we're going to then check and see if distance is less than 5 meters. This could be whatever you want to set it to, whatever makes sense. If this is true, we're going to go back, and this is where we're going to change the state. We're going to go back to our robot state controller. We're going to go here, and we're going to go through this set state. So we're going to say state controller, set state, new state is robot working RSC. So this is going to then send this, and then we're going to come back here. It's going to say, okay, cool. Now go ahead and skip to on state exit. Change your state to the new state, which we've set as robot working, and then do the robot working on state enter. All right. But we also want to go ahead and, so if it doesn't see the player, right, it should be napping. We're going to tell it to go to sleep. We're going to say the RSC get component, and this is, we're going to talk to the nav mesh agent, and we're going to actually tell it to, virtually go to sleep. We're going to say, is stopped is true. We're going to say, just stop that nav mesh agent. It doesn't need to do anything anymore. Have it go to sleep. All right. In this case, we're not going to worry about an on-state exit. This could be an animation it does when it wakes up if we wanted to. Lots of different things. It's tricky to a degree, and there's no real specifics on, especially in a small case like this, of whether it's better to use on-state enter or on-state exit. We're just switching back and forth between two, right? But let's say that this was switching between like 10 different states. If that was the case, right, we might want to make sure that on the wake up, it runs this one animation on the end of its sleeping, because maybe it could go into cleaning, moving, falling apart, right? Lots of different things. And so since we don't know, and those other ones could then switch back and forth between each other, we wouldn't want that on this on state enter. But once again, just because we're switching back and forth between two, it's not as big of a deal. Okay. Go ahead and save that, because that's all we're doing in this one. Let's go back to our working one. A lot more is going to be happening in the working. So when we begin working, we need to have our scanner. Make sure RSC scanner get component render, right? Material. We're going to do an equal sign for the right time this time. RSC red, right? So when it's awake and working, that scanner should be red. And then what we want to do, because it was set to false, we could have done this in the on exit of sleeping, but we're just going to have it here. We're going to set RSC get component. We need to tell that nav mesh agent, hey, you're not stopped anymore, you're not sleeping. So is stopped is now equal to false. Now you need to move. Now you actually need to do something. Okay. On the chick transitions, right? This is not distance based. This is going to actually be looking to see if it finds the player. So we're going to say the RSC scanner transform look at the RSC player dot transform position. Okay, so what this is doing, it is turning the scanner to look at the player. So it's going to be having its forward vector right at the player. And so then what we're going to do is we're going to send out a raycast. So raycast, it starts with a raycast hit. Whatever you want to name the variable, it tends to be just hit. That's why it auto fills it to that. So then we're going to check if physics raycast RSC scanner transform, and this is why it's going to come from the center of it. Ooh, sorry about that. It's going to be coming from center of it. So this is why this transform position, it's why we set all of the robots to layers to not interfere with the raycast. So the position, and then we're going to do RSC scanner transform direction, so where it's going. And this is, like I said, we set it now with that look. We made it look, so it's now we can use vector 3 forward. You always come out with a hit. Oops, it's not a, hold on, it's a comma, out, hit. So that's going to give us our information. And then we're going to just have this scan for as far as we want. We could have it where it only scans, 10 meters, 5 meters, 100 meters. But we're going to say math F infinity. We're going to say just freaking send that beam out as far as it goes. And so what we're going to do is see it sent out the beam. It has hit something. If hit dot collider dot game object dot name, right? So we're seeing what did it hit, doesn't equal player, right? I believe player is our player name. It is. I should actually put that because it's looking for a string player. So we're saying, did you hit something other than player? So this is where it would hit like wall, or whatever. So if it doesn't hit the player, we're going to go ahead and change the state. So we're going to do the RSC set state like we did before. And now we switch to the robot sleeping, RSC. No, not state. It's got to be sleeping. Sorry about that. Okay, so if it sends out its raycast and it sees a player, it's not going to do anything. But if it sends out the raycast and it doesn't return player, it's looking directly at the player. So we know that it should hit the player unless something's in the way. If something's in the way, it's going to return something other than player because it always returns the first thing it hits closest to the source. Then we're going to go to sleeping. So if this is the case, it doesn't see the player, it's going to take a nap. All right. But, so let's say it sees the player, right? Well, now what we're going to do is we're going to have it move. And so we're going to just have it move between the destinations at a random order, like we set up in the state controller. So like we set up here, right, it's going to pick a random destination and it's going to move amongst them. So if it's moving, we're going to once again get another, we want to know distance, right, between, we want to know the vector, the distance of the vector 3, distance between the robot, which is the RSC transform position, and the RSC current destination position. So how close am I from where I'm at right now to the destination I'm going to? And so and sometimes this takes a little bit of fiddling with, we want it to not be right on top of it. We want to go ahead and have a little bit. If that distance is less than 3 meters, we're then going, so if we've gotten close enough to it, we're going to go ahead and say RSC current destination. So we're accessing the current destination variable in the robot state controller is equal to, and we're going to call back to it and say, find a new random destination. If we are not, then RSC robot destination equals RSC current destination dot position. This is what's going to move us around. This is what's going to move that robot from its current. It's going to be head towards the destination based off of its current position, going around objects, right? Avoiding those white spaces we created. We could have it another state change. We could have it where if it sees a target, maybe something else happens, right? We could have different transitions. It doesn't just have to be this one. In this case, for the sample, we're just going through these basic ones. Okay. Whew, we made it through. Let's go ahead and save that. Make sure all 4 of them are saved. We're going to return to Unity. And then we're going to click on the body, which is the body of our robot again. And what we're going to do, and we're going to drag onto it. We don't need all of that. We're going to drag the robot state controller to it. And then we're going to go ahead and make sure we drag player to player so that it knows who it's targeting. We're going to open up the body and drag scanner to scanner. We're going to robot. Let's see. We'll drag the materials. Let's do that next. We've got blue to blue, red to red. Current destination it doesn't need because it doesn't know it yet. It's going to, like we've, if you remember in here, it's going to go ahead and set the robot itself, and it's going to set the destination, so those are good to just be nones. And then what we want to do, the easiest way to do this is with clicked on body with our robot state controller. Up here at the top, next on the inspector line, is a padlock. We're going to close that. We're going to lock this in place. So now, no matter what I click on, this is going to stay the same. So then if we come to our destinations and we select all the destinations and we just drag that to destinations, it's going to auto-populate those destinations in here. Don't forget to unclick that. Otherwise, you'll just stay there and weird things will eventually happen, I promise. Okay, we have those now all in there. And now let's go ahead and let's save this. And if all it goes according to somebody's plan, this should work. I'm going to go actually real quick just to remove some of the white in here. I'm going to go to the walls. I'm going to select all the cubes. And I'm going to, I'm just going to make them the same as, no, not the bullet. I wanted the gun. Some gray walls. Okay. So, let's go ahead and save. And if we play this, that little robot should start moving. And it's moving. And as soon as it ducks out of sight, you can see right up here, it just fell asleep. That little rascal. All right, well, let's go grab our gun because, you know, everybody needs a gun. And then we're going to come up here eventually. We're going to actually take the long way so you can see where this changes. So we're going to come up here. I need to speed up this rotation speed. This is a little slow, but we'll work on that as we continue. You can see, let me just come around here, make sure there's enough space. It should have plenty. We're going to turn. I'm going to go ahead and increase my scale. You can see now, I'll just zoom in a little bit, right? That little pesky robot, its visor is as blue, showing it's sleeping. We're definitely further than 5 meters, so we're going to sneak up on it in a moment. We get within range. There, boom, it turned red. It's constantly looking at us. It got to its location. We can see up here it's moving to its next location. And now, bam, it doesn't see us, and it goes to sleep again. So, we now have a very basic AI that can be expanded upon, right? This is just a little robot that does whatever the hell it wants to do. But it is 100% set to follow its instructions. It's going to follow those different states. And so this is where, once again, this is where your enemies are going to come from. This is where your helper AI is going to come from. I've stopped calling it bastard AI. I like narcissistic AI better. This is where that narcissistic AI would come in, right? This is a little bit more of that narcissistic AI. The robot is just doing what it wants to do for the most part. Maybe to make it more narcissistic, if the player gets too close while it's sleeping, it attacks them. I don't know. But this is where you're going to build your boss fights, right? You can have then for your transitions, I mean, obviously while it's sleeping, isn't it? But checking the transition, has its health depleted? Is it in phase 2 and its health points have depleted? Okay, now move to this state for phase 3. Those type of things. So this is where I really want you to start building and exploring. And this is actually leading to, I hope you all made it to this point in the video, because this is all going to be really, really important. Let me see if I still have it open. We are now doing our gameplay loop number 2. It's going to be due next. It says until October 13th, but that is the half credit due date. This is actually due. Let me see. It's going to be due on October 6th. So this is October 6th is coming up. That is going to be next Sunday, not this Sunday, but the following Sunday. So this is due in about a week and a half, give or take. And I want you to go ahead and create a short gameplay loop. It can be an extension onto this. But I probably would recommend restarting one, or this could be, you could use this to start building your boss fight. I want you to create a short gameplay loop that's focusing on what we've done so far, the implementation, or I should say what we've done so far with AI. So it should be an implementation of either an enemy or a helper AI, or I guess help AI, using a state machine, just like we did. The requirement for, so we had 2 states in this. The requirement for your AI is it needs to have 5 or more different states. And I will be giving you points based on those 5 states and making it clear that it moves through there. For this, I want you to just submit the playable Unity exe file plus the required build files, which I'm going to go through and show real quick here in a second, because I know a few of you weren't exactly sure what I was looking for, so I'm going to make sure it's listed here. And then please include just a short document. It doesn't need to be much. Documenting and outlining what are your 5 different states and how are they triggered and switched between during your AI's state machines running. And then throw that in that zip file as well. So let me just real quick show you what I mean by the exe file plus the required build files. So let me go ahead. I'm going to move this back out. We don't need this anymore. I'm going to come in here. I'm going to bring, where is, give me just a moment. Okay. So I'm gonna bring this up and in. So this is the folder of what this game is becoming. So what we're gonna do is we're gonna come up to File, and we're going to Build Settings. And so then we're going to, we want to make sure in scenes to build, we need to make sure there's something here. So you can add the open scene to it, make sure that it shows up. So this is called sample scene. So we have scene / sample scene. That's what we want. It needs to be a Windows, Mac, Linux build. It needs to be target platform Windows. Um, and then we're going to go ahead and build. Not build and run, but we're just going to do build. And it's going to pop open what I just shown you was our build. So this is our big Unity full entire files. Everything's here. Our assets, all way too much stuff that I don't need to play it. So what I prefer doing is then from here, click new folder. We're going to call this Gluck build. This is a little helpful for me if I get it, so it's clear whose it is. Creating a new folder, calling it Gluck build. I'm going to select that folder, and now it's going to build everything that I need to play that game into that folder. And so this will probably take, I don't know, 10, 20 seconds. Just depends upon how much is there. It gets done so many times and then moves on to something else. Perfect. Boom. It's done. And so what we have is I have the title of my game, which is section 1 part _part 1, as an exe. In there is the crash handler and the Unity player DLL, which is fine. It's already put in there. And then I have the data and the mono bleeding edge folders. This has got a little bit of stuff in it, but all of this is required to play. However, this, if we go to the properties, is currently 84, 85 megs. If I went to the full part, if you send me everything, this is a half a gig. I don't want a half a gig. So just go ahead, put it into this build folder. Once you've built it to it, come out, send it to the compressed zip folder, zip this bad boy up. Now I've got a compressed folder of about 28 meg, 29 meg, under 30, and it has everything that I need. And so then just submit this zipped folder. That's all I need. And then I can just always come in here. Oh, I'm going to delete it because I don't need that one. But if I open it up, I can just click on the exe, and bam, here I am to the game. For some reason, it fell asleep because it hid behind the gun. So obviously the gun would eventually need to have its own. And you're a little sleeping again. Oh, this worthless robot. Once again, that's all I need. If you want to go in and make it easy, I should have added it to this. Oh, decided to slam into me. Which we will fix later. If you want to add in, here, we'll do this real quick as an end part of this. So if we come in here, we've already built it, so it's perfectly fine to rebuild it again. We're going to close this. We're going to go into controller. We're going to come into our scripts. We're going to add a new script. And then we're going to go ahead and we're going to name, oh, dang it. We're going to delete that one. Let's try this again. We're going to create a new script. We're going to call it close game. And if all you want to do in here, close game, we're going to open the script. All that needs to be in the update is we'll do start is not needed. It doesn't matter. We'll just leave it. If input dot get key down key code escape application quit, save that. Add close game to our controller, save that. We can come back and build settings, build it, build, make sure it goes back in Gluck builds. It's going to update that, so now I've got the newest build in there. So now if I come through, click on my exe, it's going to go run off and have a nap. I'm going to grab the gun. I've seen enough. All I have to do is press a... Why is it not? Of course it's not. Okay, hold on a minute. Why? Hold on. So if hold on a second. Let's see if I'm right. I'm going to pause this for a minute so you don't have to watch my floundering around. But I think I know why, and I'll pop back on in just a minute. All right, I was right. So I'm going to figure this out. So just so you know, the debug log or application quit is what quits the application, but it won't run when you're just in playtesting mode. So I put it in here and realized the reason it didn't run is because we are not using the old input system. So what we need to do, so we're going to make this just a quick little add-on part to everything. We'll fix that code in a minute. We need to come into a my controls input, and we need to add an action, which is, we're going to call it quit. And we're going to add a binding. Let's see, quit. Quit is going to be a button. And we're going to add we're going to go use the back arrow. We need to, hold on. We can do that. Since we're doing this all on the controller, let's just keep it there. Gamepad, and we're going to make it the, we're going to make it the start. Let's make it the select button. So we go ahead and do select. Cool controls. Perfect. That's what we want. We're going to go ahead and save the asset. If you don't have autosave, remember to save the asset. And then we are going to come back to our code. And nope, that's not our code. That's other stuff. This is our code. We're going to come back, and like we did in the player controller, we need to make sure that we have an input system. So I'm lazy enough, we're just going to copy that over. And then we're going to use basically the same thing like we did. Jump. So we're looking for quit, right? So quit action triggered. if, we'll just add it on top, if quit no action quit is probably the wrong word for this. Button. Thank you for your patience with us. We're going to make it through. Quit. It's a button. It's not that. We're going to Alt Tab to my code. We need that public input action reference. Public input action reference. We'll just call it close game. Close game action trigger. Close game. Jumping out to lowercase. And then triggered, not trigger. Then we can application quit. I am still learning the new input system. It's not something I learned originally, a part of GIMM, and I've always hard coded everything, so I'm liking it, but I'm still getting used to the how it runs. Okay, so now I have this. Let's just take this off because it doesn't matter since we're already here. All right, we need to remember to go in to controller, close game, add quit, save. Okay. Once again, this won't run in here, so we are going to file, build settings, build this to the Gluck build folder. Now I have to remember which is the select button on my controller. Alright, it's one of these two. And I hit select, and now it closed. Perfect. So that's how we close it using the new input system. Thank you for your patience in working through that. Hopefully that was helpful, seeing that sometimes I don't have all the answers either. But we're going to make it through. We're going to work through this. So once again, this was on the AI and the closing and how to build and what exactly files I want in the builds. If you do have any questions, please reach out. I am available tomorrow virtually and Friday as well. I'll make an announcement on that as well, but I will not be coming in for office hours on Friday as well. I just want to kick this. I've had to pause my thing enough for coughing fits, so trying to get through that. Once again, if you have any questions, please reach out. Otherwise, work through this and then begin work on your gameplay loop 2 on making the AI that needs 5 different states. Have a great rest of the day.